Hey, welcome back. Common Core Algebra II. Today's notes on our 11.7 vertical shifting of sine and cosine graphs. Now, yesterday you did a great job with using the colored pencils, and I think that's a really good thing. If you're putting more than one graph on a set of axes, then please make sure you're using colored pencils. It makes it, first of all, it makes it more fun, and second of all, it makes it easier to read from a grading standpoint and from a reading standpoint and a completing standpoint. So any graph primarily comprised of either the sine or the cosine function is known as sinusoidal. All right, these graphs can be stretched vertically as we saw in the last section. All right, other transformations can occur as well. So today we're going to explore graphs of equations in the form y equals a sine x plus c and y equals a cosine x plus c. Now I'm going to remind you that when we talked about this a right here, that was called the amplitude. And that's what we talked about. That's what stretched it. So if we started with a nice sine curve that looked like this, all right, remember that when that a changed, it might have come up and it came down to the 0 and came up and looked something like that. Or if that was a negative, sometimes it reflected over that x-axis and looked like this. All right, so now what we're going to do is we're going to look and see what happens when you add and subtract a constant off the back of this. Okay, so let's look at our exercise 1. So consider the function f of x equals sine x plus 3. So how would the graph of y equals sine x be shifted to produce the graph of f of x plus 3? Now, if you remember what our pattern looked like of our unit circle, right? So I'm going to remind you, and this is what I do. I remind myself as well. All right, my unit circle, I always remember this is 1, 0. So this is negative 1, 0. And this one has to be 0, 1. And this is 0, negative 1. So as we're looking at the sine curve, reminding ourselves that the sine is equal to the y value. So that's why at 0, it's 0. At pi over 2, it's 1. At pi, it's 0. And then I can't get to this other one down here. Maybe if I slide it up just a little bit. There we go. We get to negative 1 and back to 0. So that's how we find those points on our axes, okay? Now, what happens when I add 3? Well, remember, the first one was multiplying by 3, so our zeros remain the same. So what's going to happen? Everything's going to shift up 3. So shift, let's say all points, shift up 3 units. All right, so now what is that going to look like? In B, it says graph it. So it means our 0 is going to be 0 plus 3, which is 3. And our 1 is going to be 1 plus 3, which is 4. And then it comes back down here, and back down here, and back down here. So this is what it's going to look like. This comes here now. It's going to go up to 0 and come back again. So what happens is our midline, and this is, I'm going to talk about this in just a few minutes. Our midline, which was right here at the x-axis, got shifted up 3. So from here, it got shifted up 3, 1, 2, 3. And then we drew, kind of like with a new x-axis in mind, we drew our curve. So if you can think about it like that, it makes things a little bit easier. Moving on to exercise 2. Of course, you know that if you need to write it down or pause or do anything, feel free to stop it at any time or rewind it. Exercise 2. So consider the function y equals 2 cosine x plus 1. So using your calculator, sketch the graph on the grid. We're not going to do that. You don't have a calculator at home, and I don't find the calculator terribly helpful in a situation like this. B says give the equation of the horizontal line that this curve rises and falls 2 units above. Sketch the line on the graph. So that's what I keep talking about. I haven't introduced the word yet, but it's called the midline. So I'm not going to forget about C that says state the range, but I'm just going to come up to this part. So I'm going to just write down, so I know what it is, y is equal to 2 cosine x plus 1. So reminding myself my amplitude is 2. All right, and what happens to my midline? My midline shifts up 1. So why don't we take a different color? Why don't we make the purple one our midline? So here's our midline. All right, so keeping in mind what this is going to look like, the cosine curve normally starts at, let's see what it, remember, I'm going to write it down one more time. This is 1, 0. I write it down every time. This is 0, 1. This is 0, -1. Or you can write the table down if you want to. So I'm doing cosine, so I'm looking at my x values. So at 0, which is right here, it's 1. So it's going to be 2 times 1, which is 2, plus 1. So I'm going to be up here. So 2 times 1, so I'm going to be up here at 3. And then I come back down to 0. But remember what 0 is. 0 at my midline is going to be, at my axis is going to be my midline, which is right here at my midline. So that's going to be 0. And you can absolutely do this using a table. And then we're going to come back down to pi. And pi is right here, and my cosine is -1. So it's going to be -2 plus 1, which is -1. So I come to here. And then I come back up to my 0. On my midline, plus 1, which is 1. And then I finish up here at 3. So nice curves. I'm going to remind you about concavity. Nice curves, no points. All right, it works like a valley and like a mountain, not to a point. And then we're going to continue that, and we're going to just mirror image this across our y-axis. So it looks something like this. So we start here, nice curve, comes around, and nice curve back up again. And then it says state the range of this trigonometric function on the in-interval notation. Well, reminding you that interval notation means it starts and stops with square brackets because it includes the bottom bound and the top bound. Well, my bottom bound is down here at -1. And my top bound is up here at +3. And what would the domain of this function be? -infinity to +infinity, because it keeps going and going. So this is where I actually talk about what the midline is. All right, so for curves that have a general form of y equals a sine x plus c and a cosine x plus c, the value c is called the midline or average value of the trigonometric function. It is the height or the horizontal line that the sinusoidal curve rises and falls above and below by a distance of the absolute value of a, which is the amplitude. All right, so now let's see what happens when we put a negative sign. Instead of being a positive c, we're going to have a negative c. So exercise 3 says, sketch and label the functions y equals sine x minus 2. Why don't we do this one in blue? All right, and we'll do the second one, the y equals negative cosine 2x plus 3, all right, in red. Now, if it's easier for you, you can come up with a table. All right, so you can come up with a table, and you can even put the table above your curve if you want to. But no matter what you're starting with and ending with, it always starts here. 1, 0, -1, 0, 0, 1, -1, oh, see, 0, -1. There we go. So I know here that the sine of x is going to be the sine of x. Which one are we doing in blue? The sine of x sits right here. It's the y value of 0. So I know this is 0. So 4 times 0 is 0. And 0 minus 2 is -2. And then, so first of all, where's my midline? We didn't talk about that very much. So midline turns out to be, where's that purple marker again? Down here at -2. So my 0 now is at my -2, and that makes sense when I put this point right here at 0, which is really -2. All right, so now at pi over 2, right here, here's my sine of pi over 2, it's 1. So 4 times 1 is going to be 4, and 4 minus 2 is 2. So at pi over 2, I'm at positive 2. Then I come back down to my 0, and because my amplitude is 4, notice how I'm going 1, 2, 3, 4 units above my 0. I'm just going to slide this a little bit down so I can get to this point down here, 1, 2, 3, 4, and I come back to my 0, which is here. So this is what my first one looks like. Goes up, comes down, comes up. And let's keep just following that around. So we're going to come down here. We're going to come up here. We're going to go up to here and come back to our 0. So the rest of the curve, again, you might be able to do this with or without your table. All right, now it says, what's the range of this? This is the one we just did right here. 4 sine x minus 2. So what's the range? Well, the range goes from this point, 1, 2, 3, 4, 5, 6, from negative 6 all the way up to positive 2. All right, so now, if you wanted to make a table, because that might help you just a little bit. So here's my theta. This time we're going to be doing cosine, so why don't we put cosine theta here? And then we'll do negative 2 cosine theta plus 3 down here. And the table might help you. So let's just start at 0. It's a comfortable place to start. So at 0, the cosine right here, let's do this one in green. The cosine at 0 is 1. So what's negative 2 times 1? Negative 2. And negative 2 plus 3 is 1. So I know at 0, I'm at positive 1. Now this one, I'm not going to use my midline. I'm just going to use my table. So now my next one is pi over 2, which is 90 degrees. So that's up here. And my cosine of pi over 2 is 0. So negative 2 times 0 is still 0. 0 plus 3 is 3. So at pi over 2, I'm at 3. So I'm up here. The next one now is pi. At pi over here, here's my cosine, which is negative 1. And I'm going to say negative 2 times negative 1 is positive 2, and positive 2 plus 3 is 5. So at pi, I'm at 5. 1, 2, 3, 4, 5. Now I'm at 3 pi over 2. At 3 pi over 2, my cosine right here is 0, and 0 plus 3 is 3. So now I'm back at positive 3. And at my 2 pi mark, I should be at the same place I was at 0. So if I did that right, my 2 pi, again, I'm a 1. So I'm 1 times negative 2, which is negative 2, and negative 2 times, well, I'm sorry, negative 2 plus 3 is 1. So I'm back at 0 again, so at 1, 1. So I can see how my curve now is going to look something like this. All right, so you should be able to tell what your midline is. If you don't know, it's going to be, what is it, plus 1? So it makes sense that it's going to be right smack in the middle of this, which is going to be right here. So there are my zeros. So what does the rest of this curve look like? Well, guess what? You can just reflect it and finish it off. So there's the second one. And this one asks what the range of it is. So the range of this one, let's see, the lower bound is positive, is negative. No, it's positive 1. Okay, almost lost it there. So positive 1 is my lower bound right here. My upper bound is right here. So 1, 2, 3, 4, 5. My upper bound is 5. So, two ways to do it. One way is a little bit more intuitive than the other way. Using your tables might be a really good choice for you until you get very comfortable. But every single time I do one of these, I manufacture my unit circle and I work off of that. And whether you work from a table from that point or you work directly from your unit circle, it doesn't matter. Whatever works for you and whatever keeps you from making mistakes. All right? We're going to move on to exercise 4. Which says determine the range of each. So determine the range of each of the following trigonometric functions. Express your answer in interval notation. So you have to kind of think about what this looks like. Like, you know, maybe if you draw a little line, right, a little axis like this, I know that my midline is going 4 up, right? So I know that I'm going to go 4 up. So let's say up here is my midline. And then from that midline, I'm heading up 7 and down 7. So 4 plus 7 is going to be my upper bound, and 4 minus 7 is going to be my lower bound. So negative 3 comma 11. Okay, I'm going to do the same thing for this one. So what is the midline? Midline is right here at positive 2. And from there, now don't worry so much about the negative, because remember, that's the amplitude. It tells you going 5 in each direction. So you're going to add 5 here, and you're going to minus 5 here. So on this one, this is going to go between negative 3 and positive 7. Now you can even get to big ones like we are here. So you don't have to actually draw these to scale. So the midline here is going to be at 35. And then our amplitude is 25, which means we're going to go up 25 this way, and we're going to go down 25 this way. So what is that range going to look like? It's going to start at 10, and it's going to end at 60, because 35 plus 25 is 60. We have one more to look at. Exercise 5. The graph below shows a sinusoidal curve in the form y equals a sine x plus c. Determine the values of a and c. Show how you arrived at your results. So already I can see that my c here is going to be my midline. And that's going to be the line that falls right here and through the middle. So we have to figure out what that is. How could we do that pretty easily? Well, you know this is 6, my y, and this is 22. So can you take the average of them? Can you do 22 plus 6 divided by 2, which is 28 over 2, which is 14? I think that works. All right. So we got that to be 14. So now what's the amplitude? Well, if I know this is 14, notice how this is a little common sense going on here. Nothing all that complicated. So how much do I have to subtract to get to 6, and how much do I have to add to get to 22? Well, I think it's pretty obvious that the answer is 8, because 14 plus 8 is 22, and 14 minus 8 is 6. So basically, let's rewrite. So I know that a is equal to 8. So my answer is y equals 8 sine x plus 14. All right, this says to explain, or this says determine, show how you arrived at your results. I think, see the word show? Show means that sometimes it's not all about explaining and using words, but showing. So if you showed this work that's right here, all right, how you got 14, you might have to be a little bit more specific on how you found 8. So maybe some words here might say, well, I know it's going to be 8 units to get to 6, and I know it's going to be 8 units to get to 22. So on that one, some words might be necessary, and I please encourage you to use your words if you're not sure if you've explained it enough or shown enough with your mathematics. Okay? Please don't lose points on silly things like that, especially when you got the math correct. So until next time, I know you're sick of hearing it, but please always make good choices. We don't always, but we do the best job that we can. Okay? So see you tomorrow.